Good morning, or well, good afternoon to all of you. Thank you, Adiseo, for giving me this opportunity to talk to you and share my experience on mycotoxins, how they affect the animal's functioning, the reproductive, digestive, and the respiratory system, and what can be done about it. So we will first highlight a little bit the situation globally, then the mode of action of the different mycotoxins, and then what I am, a vet. I will highlight the veterinary aspects of mycotoxins in more species, but of course my expertise is poultry, so I have a small video to show you where you can find the lesions in poultry. Then diagnosis is very important and not easy for mycotoxins, and then what can you do about it. So if we look globally, today, and Adiseo contributes to examine and take samples from different parts of the world to see what is the situation. What we see is that a lot of our animal feeds are contaminated with mycotoxins. There are aflatoxins, zearalenone, fumonisin, DON, ochratoxin, and very often they come together. If you find one mycotoxin, usually you have more of them. That is the rule when we look at those samples. And then what we also, or what is not always clear, is that what is the effect of the subclinical levels of mycotoxins. As we say, usually it is multi-contamination and different mycotoxins, all in different levels, and they also have a synergistic effect. So 1 + 1 is 3 in case of mycotoxins. Most of the samples that we find can even comply with the European regulations or recommendations on levels of mycotoxin, what is the maximum tolerable concentration in feeds. We have regulations on that. But we also know that even if they do not reach that level, there is still an impact on performance. There is still an impact on performance and health of the animals. So we are talking here of a not so easy to diagnose problem, and a problem that is mostly underestimated, because we measure mycotoxins very often, but we also have metabolites from the mycotoxins that also have an effect, or modified mycotoxins. And recently, research has also shown that there are many emerging mycotoxins where we still have to examine the effects, like the eniatins, bovaricin. All these things are still to be examined. So here we have a few overviews or examples of samples that have been examined all over the world. We have some figures from cereals and corn in Poland, Spain, but also US, France, UK, Brazil, so Russia. So this is really a global concern. There's not one country that can say we do not have. Also in Belgium, on our wheat that we harvest here, we also sometimes have mycotoxins. And so, as we said, it is a global threat, and what we fear is that with changing climate conditions, this is not going to reduce, but it's probably going to enhance the occurrence of mycotoxins. So we will see that, and like we see with insects also, and intermediate hosts of some of our parasites, is that they are moving up with global warming. So mycotoxins today for our animals, production animals is mainly what we are talking about today, is definitely a major problem, but we not always see a real acute disease, like acute mortality, or so the effect is more insidious. So we have clinical or we have clinical disease, but mostly we see subclinical disease. And that is why we need more performing diagnostics to be able to also detect this. So even if there is only low or moderate levels of toxins, they can still have an effect on metabolic, physiologic, immunologic functions of the animals, and so it will affect health and performance. The other thing to be aware of is that there is a risk of human contamination, depending on which products we are dealing with from the animals, but we know like aflatoxin can pass in the milk of the cows. We also know that there is proof of aflatoxin in eggs, so it can also contaminate the people eating the eggs, and in meat, although that is more rare, but there is a possibility. So one of the concerns of mycotoxins is also human food safety. So that is why monitoring in feed and food is important, not only to determine can we use this raw material for the quality of the feed, but also food safety. And then the next step that we are coming to now slowly with biomarkers is how can we measure exposure in the animals? Because that is what we want to know. How much risk is my chicken or pig or cattle at by eating this kind of feed? So the different mycotoxins in this table, I wanted to highlight their mode of action and then also the main target organ. I know this is not a complete list, but when we talk aflatoxin, we know this has an effect on your DNA, RNA in the liver mainly. It also is carcinogenic, but the organ that we will, in the lesions of acute intoxication, the target organ is definitely for aflatoxin will be the liver. So for the trichotechins, DON, T2 toxin, they have more an impact on protein synthesis, so they will inhibit this protein synthesis, which of course is happening in different parts of the body, but the main effects that we will see is intestinal mucosa. It is caustic for the intestinal mucosa, also for the skin. But as I said, I wanted just to highlight the main target organ to make it easier for in the field to what organs are we going to look at for the different mycotoxins. The zearalenone, we know that has a big effect on estrogen receptors. So of course the reproductive organs here will be the target, main target organs, as well in the male as in the female. Then fumonisins they can inhibit the sphingolipid biosynthesis, which is very much implied in the nervous system. So that is why with these mycotoxins, we very often see the clinical lesions in the nervous system, although they also can affect intestinal tract. We know that, but as I said, focus on the main target organ in clinical symptoms. And then ochratoxin A disturbs the physiology in cellular physiology in many ways, but very often the first signs that we see are in the kidneys. So that is, we will see in the different species, ochratoxin, first clinical signs or lesions we will find in the kidneys. So let's come to what my talk is about. What, as a vet, or what are the health signs that we can see in mycotoxins in the different species, and then focus on poultry because that's my expertise. So if we look at the different mycotoxins, we can see that they do have an impact on general animal health. As we can see, the circulatory system, heart, lungs, respiratory can be affected. Also the brain, we see sometimes, like even with aflatoxin, we can see paralysis sometimes in poultry, for example, but we have other syndromes with the fumonisin in quail or horses, for example. Then the intestinal tract, and that of course is very important because everything you put in, the feed you put in that is contaminated with the mycotoxins, so the first target will be there in the stomach, and you will see how it affects really the basic functioning of that intestinal tract. And then the liver, of course, also together with the kidneys, a very important organ for detoxification. So if your mycotoxin is going to affect liver or kidney, it will have a general impact because your normal detoxification processes are well, compromised. And then something else that I, in my personal experience, have come across a couple of times is that mycotoxins can have an effect on your reproduction, breeding. What we know, parent stock, so the mothers of the chickens the chicks we want to produce, if they are affected with mycotoxins, this can have an effect on their performance, but also on hatchability and on the growth, the quality of the day-old chicks, which is in poultry production, one of our main targets that we want to achieve. And then in general, it affects the immune system. That has been proven in many studies, but this is something that is sometimes, we talk about subclinical levels. How are you going to prove that the reason why you have so many other diseases, in fact, is because you have mycotoxins that compromise your body defense mechanism? And in general, if we look at the effects that mycotoxins can have on animal health, it's always a mixture of all these three parts. You have the mycotoxin, so of course this is going to the dose that you have there, the type of mycotoxin, the time of exposure, which is also a very important factor when we talk about clinical, subclinical effects of mycotoxins. And is it one mycotoxin, but as we said, very often you have multiple mycotoxins. So that is one aspect that is going to have an effect on what it's going to do to your animal, but also the animal itself, of course, depending on the species. We know poultry, for example, they are maybe the less sensitive. So what happens sometimes is that feedstuffs that are not going to be used in cattle and pigs because they are more sensitive species, are going to go into poultry feed. And of course, maybe the level is not going to be high enough to get clinical symptoms, but it will still have an effect. So species, breed, different layer birds or meat production birds, but of course in pigs also you have the different categories, dairy cattle or meat cattle, age, gender can have an effect. If we talk about reproductive systems, which will, if your males are also affected, it will have a general impact on fertility. Health status of the birds, if they are already, well, in less good condition because of parasites, coccidiosis, I don't know what, it will also affect, and of course, functioning of the immune system. In every species, we have diseases or conditions that can affect your immune response. And then the third factor, also very important and cannot be neglected, is of course the environment where we keep our animals. So good management, biosecurity, hygiene, good conditions in general in the housing of our animals is important, and will determine, all these three factors together will determine what are you going to see in the field. So this is a slide that I borrowed from Günther Antonissen, professor at the University of Ghent, and he's done a lot of work on mycotoxins. And I think this is very important for all the rest that we are going to develop, because this slide talks about what are mycotoxins doing in the intestinal tract. First of all, what we see is that it's going to affect intestinal permeability. We see here the different mycotoxins. All of them have an effect on the permeability, which means that once you have mycotoxins in clinical or subclinical levels in your intestinal lumen, it's going to affect those tight junctions between the intestinal epithelium. It's going to make that you get a leaky gut. Not only the mycotoxins, but all other substances that are supposed to stay outside of the bird's circulatory system are going to be able to enter the circulation. So we have an effect on inflammation. They induce oxidative stress, which of course is something that is not compromising the normal functioning of your gut. And very important, there will be a shift in intestinal microbiota. Most mycotoxins will have an effect on that and will make, for example, that the commensal community of bacteria will be compromised and that pathogens or pathobionts that are there take the opportunity to do harm in the intestinal tract. So also an effect on local immunity, IgA production, and recovery of your cells. So cell proliferation is something that is needed to, if you have an injury, to recover, and this is compromised in with many of the mycotoxins. So how would this modulation of the intestinal function happen? Even at subclinical levels, you will, looking at what happens in the former slide, you will see that there is an effect on the physiology, immunology, and the metabolic actions happening in the intestinal tract. And the consequences are that it will affect your performance because there is no normal digestion and absorption of nutrients because of the damage done by the mycotoxins. This increased permeability will also compromise the normal mucosal barrier function to keep out the bad things and to absorb the good things. And we will have, in general, more susceptibility for any infectious disease. So that's why the effect of mycotoxins in the gut is so important. So let's have a look at the different species, what you will see in clinical manifestations of mycotoxins. So that means that you already have a high level, but you will have in swine, but in all species, reduced performance. Reduced performance also because the feed utilization and efficiency of digestion is compromised. We get impaired fertility, and you can sometimes see tail necrosis, ear necrosis in swine, skin lesions. Same in poultry, reduced performance. One of the things we often see is the fatty liver. An effect on egg production, also on the quality of the eggs. We see sometimes meat spots, blood spots due to mycotoxins. And in the end, because of a general effect on performance, you will get poor carcass quality. And then in horses, for example, we have this syndrome where you see neurotoxic lesions. And even in fish, because don't forget, this is also important for fish, we will see that they have abnormal body conformation and also lesions that resemble a little bit what we see, for example, with Sierra Leone in swine, that you see protrusion of the anus, for example, something that we can see in fish. So aflatoxins, main target organ, the liver. You can see here we have a normal colored liver, and all these are different levels of aflatoxin that cause fatty generation. You also get liver affection in the pigs, for example. Ochratoxin A, typical target the kidney. You can see pig nephropathy, so necrosis and lesions in the kidneys as well in pigs as in broilers, where you can see swollen kidneys. And then the effect on the reproductive tract of Xylella neone. Here is what you see in young female pigs, and also abortion, also an effect on the reproduction. Here what we see, this is in chickens, where you see cystic oviducts. This is a sign of Xylella neone, and very important, this is a normal testicle of a male chicken, and here we see with mycotoxins atrophy. Of course, this is not going to give you a lot of chicks. And then nervous signs in, you see this poor horse suffering from equine leukoencephalomalacia, but also in quails we have a nervous system with nervous disorders with this mycotoxin. Then if we look at DON and T2, as I said, the intestinal tract is very much affected by the caustic effect, but also the lesions that you see on the little piglet and the tail necrosis in this sow. No, it's not a sow, it's a boar, sorry. I'm not a pig specialist, but I should be able to see this. Then ergotamines, one of the mycotoxins that we know for many years. It's even in some paintings of our famous Peter Bruegel, where you see in humans skin necrosis, but we also see that in these are calves with skin necrosis. Here you see it in a chicken, and here the ear necrosis in pigs. And here are the fish effects that they saw in rainbow trouts with DON, where you see that the body of this fish is not completely normal, a big belly, and then the protrusion of these, this anus, in fact, and you also see kidney and liver lesions. So this has all been described in literature. And then I would like to come back to what I know best, is poultry pathology. And here we see, and I have a small movie on that, gastrointestinal lesions, feathering, the liver affected, sometimes subcapsular hematomas. Egg quality, what you see here is damage done by ochratoxin, also kidney problem, bruisings, the blood clotting can be affected by mycotoxins, and even lameness sometimes. So let's watch together the video that we prepared for you on necropsy. So what I want to show you is how we can do necropsy on this layer. And we will focus on where you are looking for lesions caused by mycotoxins. So these are normal feathers. You will see with some mycotoxins like trichotoxins, DON, you can have lesions of abnormal formed feathers. So this is where you could see abnormalities when the feathers are not normally developed. So this is how normal feet and toes look like. In some conditions caused by mycotoxins, specifically ergotamines, you can see necrosis of the toes. So then we'll inspect the head and the mouth cavity, where you can see here the choana that are clear. It's the top part of the mouth, in fact, connected with the nose also, and also the tongue. This is a normal tongue. If you have mycotoxin intoxication in acute cases, you can see lesions on the mucosa of the mouth, here on the choana. Also, the tip of the tongue can be necrotic, turns out black, and you see kind of ulcers also on the side of where the beak ends. So we open up the abdominal cavity. So this is a young layer. And here you see the organs in situ. Immediately you can see the liver. This is reddish, brownish. That is a normal liver. In cases of intoxication with aflatoxin, for example, you get fat deposits, a fatty degeneration of the liver. So you will have more orange, even yellowish liver color. So we remove the intestinal package. And what we can see here is a normal aspect of the intestines. You don't see any hemorrhages. This can be the case in some intoxication with mycotoxins. You can see hemorrhages on the intestine, big spots of hemorrhage. So then we will open up the stomachs and the proventriculus, because there also sometimes you can see lesions. So this is the proventriculus that we open up, and in some cases also because of mycotoxins you can see hemorrhages here in the proventriculus. Then we open up the gizzard, because this is also where we will look for lesions. We remove the contents, and then we look for ulcers. So this is normal aspect of the gizzard inside. So in case of mycotoxins, you can find lesions, ulcers here, but mostly also on this side. Sometimes you can only see it when you remove the kaolin layer, so underneath, but in fact all these ulcers are due to caustic effect of the mycotoxins. So this is the inside of the gizzard, the mucosa without the kaolin layer, and in case of intoxication with mycotoxins you can see ulcers when you remove the kaolin layer, also sometimes even with the kaolin layer on top of it. You can even find that in very small chicks, maybe due to breeder intoxication. So then we have a look. This is a layer where you can see the immature ovaria. It's a young layer, and underneath you see the kidneys, and this is the normal aspect of kidneys. They are reddish, brownish color, and you don't see any in case of mycotoxin intoxication, for example with ochratoxin, you can sometimes find or very swollen kidneys or signs of urates inside the kidneys. So this is a young layer. What we see here is an ovarium that is not yet developed, but we know that some mycotoxins also affect the reproductive tract, as well in the female as in the male, where you can get regression of your ovaria, and you can also get testicles that are undersized, so atrophy of the testicles, and of course this will have an effect on your fertility rate and hatchability. So I hope you learned something from the necropsy session, and so what I want to highlight, because in poultry production this is of course very important, is the performance of the breeders, and they can be affected by mycotoxins. What we will see is that in bad cases even your feed intake will be lower, and of course your feed conversion will go up. Your efficiency of transforming feed into meat or eggs is lower. So an effect on your production, less eggs, and even the ones that are produced can have reduced hatchability. The end product of breeder production is quality chicks. So mycotoxin can have an effect on your shell quality, also on the hatching process, because if your shell quality is not good, during incubation, you will have altered moisture loss, and also the exchange of gases in bad quality shells is less good, so it will have an effect on chick quality and more embryonic mortality. And also sometimes we saw some of the mycotoxins affect really DNA, so you can really have deformations. Egg weight can be lower, fertility goes down, more mortality as well in the breeders as in their progeny, and the chick quality goes down. So if you look at egg production and embryonic mortality, there is a connection in the sense that these studies are with effects of aflatoxin and ochratoxin, but also the other mycotoxins can have an effect on egg quality and embryonic mortality, because as we said at the start, there is the effect of your mycotoxin in the intestinal tract, which will compromise nutrient absorption, but also calcium and vitamin D3 absorption, which you need for the production of a good quality shell. Then in the liver, you will have the protein synthesis that is compromised, so that will also affect the transport of calcium in your circulation, also other pigments like vitamin A that can also be affected by the mycotoxins. And then in the kidney, you have more excretion of calcium, which means that there is less available for good shell production. The plasma concentration of calcium and phosphorus is going down, more calcium is going to be mobilized from the bones, and this will result in thinner eggshells. During incubation, this has an effect on exchange of moisture and gases, which will affect the condition of the embryo, and you will get more embryonic mortality. So here in these graphs, you can see, and the important is to note what I put there in green is that the concentrations were within the EFSA regulation range, but still you can see with different mycotoxin, ochratoxin, aflatoxin, and it also states when or the exposure of days. Also with DON, you have an effect on egg production and consequently also on embryo mortality. So these are the effects that you can see with exposure, and as I say, important to note is that it's not even in concentrations that are higher than what is determined in the regulation. So what you saw in the graphs is a synergistic effect, what we usually see with mycotoxin of ochratoxin and aflatoxin. And important to remember is that these mycotoxins can also be transferred to the egg, so they have an effect on the chick, of the embryo. So the chick, there can be embryo mortality, or a chick that is born but with a compromised immune system, with lower transfer of antibodies through the yolk, with lower weights of the immune organs, the bursa fabrici and the thymus, and so that makes that your chicks will be more susceptible to infections and you will have early mortality. So then diagnosis, as I said, not always easy if you have subclinical infections with or contamination with mycotoxins, and then you, as I said, you see other diseases, you see other problems, and to relate that to mycotoxin can be a challenge. For example, reduced hatchability before you come to the feed of the breeders and find mycotoxins there, sometimes that's a long way to go. Because, and also in this case, for example, what we saw were ulcers in the gizzards of day-old chicks, and in the end we could prove that there was a problem with the feed of the breeders. But of course, there are other reasons why you can find ulcers in the stomach. Can be high temperature in incubation, or adenovirus, for example. So it's important to monitor in the feed or the food for humans, for the quality of the feed and food safety for people, but also for our animals. So already it starts, for the monitoring, it starts with the problem of the sampling, because mycotoxin contamination is not uniform in a batch. Say you have a boat that arrives with corn from I don't know where, and you want to check for mycotoxins. The way you sample is very important, because you can have hotspots with contaminations, and if you don't do a good sampling, then you will have a problem. So that is one aspect, and the other one is that if we want to see, or are mycotoxins implied in problems that I see in the animals, then what we want to get in the picture is the exposure to mycotoxin in the animals, and therefore, or humans, and therefore we make use of biomarkers. So we will look at bodily fluids, blood, urine, feces, sometimes meat, milk or eggs, and then we will see, we will try to find the mycotoxins, and also we can look at biomarkers of effect, biomarkers that indicate inflammation, biomarkers that indicate lower immune response, for example. Important, I'm not a specialist in that, but you have different analytical methods depending on what you want to prove or what you want to find. You have very specific qualitative and quantitative analysis, where, for example, for legal regulations, and some of them will, like the high-performance liquid chromatography, you can identify single mycotoxins. You also have tests, the liquid chromatography, mass spectrometry, where you can have a different or multiple analysis of different mycotoxins. And then we have cheaper rapid screening tests in ELISA, so they can give you a good idea, but of course this is not very, they are less sensitive, so usually you will do a screening and then afterwards a more performing test. So depending what you are looking for, what type of matrix you are examining, you will have a different test. And then a brief word on the biomarkers, because they are very useful, because they will show you really in the animal what is happening there, or what are the levels of mycotoxins. So there is a lot of work going on in that area. Some of it is done at the University of Ghent, where, for example, they looked at to see if some mycotoxin binders or detoxifiers, what is the effect in the broiler or in the pig, and therefore they saw that for pigs there is a good correlation between the concentration of mycotoxin in the feed and in the animal, in the pig. For broilers, we are still on the way. I'm sure we will soon find better biomarkers, but so it's important when you work with these biomarkers or look at results that you take into account, is this the best marker in this, for this mycotoxin, for this animal? Because you can look for the mycotoxin, maybe for metabolites of mycotoxins. What is the best matrix? Is it blood, plasma? Is it urine? Is it feces? Depends on the species, on the mycotoxin. Also, the timing is important. So when are you taking this sample? When do you expect the exposure has taken place? Because that, of course, will influence the content, the concentration of mycotoxin or maybe metabolites. And then the toxicokinetics for each mycotoxin is different. So that is also something to take into account when you choose biomarkers. So we have good proof we have some trials done in broilers for aflatoxin DON OTA, and for pigs with DON and zearalenone, that gave us some good results. So here in this study from Tommy van Limbergen, he saw a good correlation between the feed and the plasma of DON. Higher level of DON in the feed, higher level of in the plasma, and that was correlated to a tail necrosis in the piglets afterwards. In the broilers, the test that, the trials that, this is from a trial that is well, not yet published, but in any case, they didn't see a very good relation. So where the search for biomarkers in broiler is ongoing. Sorry. So biomarkers, I would say in broilers, the golden standard remains feed analysis. And then control and prevention, we also have to, as we saw what mycotoxins can do, we can do some symptomatic treatment, try to support recovery. Intestinal health is very important there, anti-inflammatory, antioxidant, support liver and kidney function, and help detoxification, yes, because that is what the mycotoxins are doing damage. And then important in your mycotoxin control is to have an integrated approach. It starts at the harvesting in the field already when the plants grow, and you have to go on with your surveillance until it reaches the animal. So good agricultural practice and good manufacturing practice are necessary for that, the right processing techniques, and then make sure there are good feed additives that can bind mycotoxins or can modify mycotoxins, but you always have to be aware about efficacy and safety, because if you overdose, you might have a problem. It can also, for example, capture vitamins and other needed substances. And no, there is no mycotoxin detoxifier that is universal for all mycotoxins. So the substances that we use, they will suppress or reduce absorption of the mycotoxin. They will also help excretion, so that the exposure time is reduced, and they can also have an effect on the mode of action of the mycotoxin. So make sure that you be aware that if you use too much or the wrong binders, that you can have a problem with minerals and nutrients that are absorbed. So that's the end of my presentation. My take-home message for you is that you must be aware of mycotoxins. It's a global concern, and it's from many evidence sampling, we know that there are a lot of mycotoxins there, and that sometimes they are subclinical, but they do have an effect. Clinical symptoms are maybe rare, but if you have them, then you really have the tip of the iceberg. But most commonly we see subclinical effects, so it affects intestinal integrity, immune response, so more other diseases. So important to do a good monitoring on the feed and the food to assure quality of the feed you give to the animals and to assure food safety for the human consumer. And in the future, I think we will find better methods to find or give evidence of the mycotoxins in the animals with biomarkers. So for the control, we have to rely on an integrated approach from the field to our table, and we have to avoid, of course, contamination before the feeds are ingested by our animals. And if we have problems, we need to focus on the target organs to make sure that we protect them so that our animals can be healthy and performing well. Sorry. So with that, I want to thank you for your attention, and I'm ready to answer any questions if you want.
Okay, so we are back here on stage to answer your questions. You can use the chat mode to type your questions, and let me just explain that to the Spanish and Portuguese speakers as well. Bueno, gracias. Se pueden inscribir ahí en español si quieren. Podemos hacer la traducción para de las preguntas. Y también, solo un poco me voy a hablar en portugués también. Quem quiser escrever em português, perguntas, por favor, fique à vontade. A gente pode fazer a tradução por aqui. E vamos responder com certeza em inglês, mas depois o Matheus pode mandar a resposta em português, se precisar. Okay? Okay, so first question, let me just translate it. How long is the time of exposure for a toxin to start to make an effect on breeders and layers? Ask that to Dr. Julia Dvorska.
Yes, this is very important for breeders, for layers, since they are living longer lives than the broilers chicken. And time of exposure depends on the type of the mycotoxins. And the longer exposure, the more effect we will have, and the more pronounced negative effect we will see. And it also depends on many other factors, like again, type of mycotoxins and health issues, any sanitary issues on the farm. For example, if some challenges on the farm are also present, so there are a lot of factors which are important. But again, for the layers and for breeders, they're really important. They can have effect even on the progeny in breeders. So if we have mycotoxin in feed of breeders, we will have negative effect on all the systems, including immune system, antioxidant system of broiler chicks. So including all the negative effect, like decreased hatchability, decreased fertility, and decreased health status.
Okay, thank you. Next question would be, the fuel levels of contamination showed in the presentation are very high. What will be the impact in broilers of more real-world levels? Let's say 5 to 15 parts per billion of aflatoxins, or 250 to 750 ppbs of DON, or 500 to 1500 parts per billion of homonicin. Dr. Olga Verkieva, if you can answer
that. Yeah. So, of course, all studies, or scientific studies, are done with high levels of mycotoxins in order to see really a pronounced effect and significant effect compared to the control group. In the field, we see different levels. They are normally lower. But again, the effect depends a lot on a combination of mycotoxins. If it's just one, like aflatoxin, or it's aflatoxin in combination with DON, with zearalenone fumonizins, or DON zearalenone also can have synergistic effect, and so on. Also, it's important again that the status of animal, as Julia already mentioned, that the more animal is challenged with other factors, stress factors, the more susceptible it is. If I just refer the levels like aflatoxins, 5 to 15 ppb, that probably you will not see the typical symptoms like liver issue, but what you can see definitely, it could be a lower response to vaccination. Same for deoxynivalenol. In Odisea, we even did a trial with 500 ppb of deoxynivalenol. And here there was a question regarding 250, 750. So in average, 500 was already significantly affecting the antibody titers against Newcastle disease. Regarding the fumonizins, 500, 1,500 ppbs, I would see a single fumonizin at this level would not really pose a big risk, especially in poultry. In poultry, you would need elevated levels above 5,000 ppb of fumonisin and higher. Pigs are more susceptible to this mycotoxin. And 5 to 10 ppbs of ochratoxin, I would say there will be no big effect.
Okay. There's just a follow-up here question on that one that asking about the combination of DON and fumonisin in broilers.
Normally, these mycotoxins are recently studied together or single as precursors of gastrointestinal problems, for instance, necrotic enteritis. But if we refer to the paper of Günther Antonissen from Ghent University, who did his PhD on deoxynivalenol and fumonisins, the deoxynivalenol levels were really low in order to provoke necrotic enteritis. Fumonisins, you really need a high level. In combination, it's could be synergistic effect, but I don't see a big issue at levels you mentioned. So if you have 500 DON and, for instance, 1,000 fumonisin together, that probably you will see more effects of deoxynivalenol, and this will be a gastrointestinal integrity challenge and vaccination efficacy. But I don't see that there will be issue typical for fumonisin.
Okay, thank you. Next question. The question in Spanish here, I'm going to translate. Is it important to also measure mycotoxins in the final feed, the pelleted feed for animals? Dr. Dvorsky, if you can answer that.
As we have just heard from Hilde, she mentioned that the feed analysis still are like golden standard for mycotoxin determination. So we need to analyze final feed to get an idea of what we have in the feed, because we can analyze feed ingredients like corn or wheat and have some ideas what we could expect, but the final feed is like mixture of all ingredients. And yeah, I think that the final feed analysis is like golden standard. So before we get this feed to our animals, right?
Okay, thank you. There's another question here asking if the organs, just like liver, gallbladder, and reproductive organs affected by mycotoxins, then how we improve the function of these organs. I don't know who prefers to answer that one, Dr. Porskar, Dr. Verkeva.
I can do this. So of course it depends how big is the damage and what is the organ, because sometimes you can really help like liver or reproductive system to get rid of the toxic substance, help to recover, but sometimes changes are irreversible. For instance, if we speak about kidneys, lungs. So normally, first what you have to do is just to prevent the further load of mycotoxins through the feed. So you have to use really a product which is controlling the load of mycotoxins or decreasing the bioavailability of those mycotoxins. And if we speak about liver and gallbladder, of course, some additives, hepatoprotectors. Of my knowledge, one of the best and fastest working in some herbal extracts with direct effects on liver, like extract or seeds of milk thistle, rosemary, maybe some vitamins as well. Donor of methyl groups can help. For reproductive system, you can get rid of mycotoxins in several days quite fast because it's self-cleaning if you remove mycotoxins from feed. So you can see the effect within 1 week already. For liver, you would need a little bit longer.
Okay, yeah, we have time for one more question here. Is there a critical age or period for laying hens, and I'll also add breeders, where mycotoxins affect more their performance and health? Dr. Julia?
Yes, for breeders, there are at least 3 critical periods. One of them is the first week of their life, when they are still developing all the systems like the digestive system, and they don't eat much, so it's a very important period in their life. And if we have mycotoxins during this period, we can damage all their future development. The second period is before they are starting to lay, and in this period they also have the development of reproductive system. And it's also very important. If we have like zero linon in this period, we will damage this development and we will not have the good development. And number three, we have a lot less time. So the number three period is the after peak period of laying, and again during this period the mating process will start soon, and so it's very important to have the very good quality of feed to have quality chicken and to have quality mating process and hatchability, fertility, and all necessary parameters for the breeders.
Okay, thank you. Well, then I think we get to the end of the 1 hour meeting that we had. Thank you very much, all you, for joining us today, and I hope to see you again on May 4th for the 4th episode of the MycoInfo, where we have Dr. Peter Surai talking about mycotoxin and oxidative stress. Thank you very much, and Matheus, if you want to just say a few words. Thank you, bye-bye.
Apenas agradecer, obrigado a todos pela presença, bye bye.
Thank you, bye bye.